All right. Everybody, I'm Kyle from this group. It's a great crowd tonight. I mean, this is awesome. I hope everybody is ready with a 10-minute long little spiel about whatever. So yeah, this is Lightning Talks. You're at Triangle JavaScript. I hope you enjoy yourself. So we've been talking about this for quite some time, and it's finally happening. We used to do beer.js like once every 2 months. But Ian got one all set up for us. And if you haven't been to the Raleigh Beer Garden, I highly recommend you go. So we're going to be there, what was that, October 6th. It's a Tuesday night at 7 p.m. So the way these work is you show up and you drink beer and you hang out. You can bring your laptop out if you want. I mean, it's just meant for fun. So got that coming up October 6th. October 21st, I haven't got it on the calendar yet, but I just was able to get it booked yesterday. Nate Hunziker he's one of the Hunziker, he's going to kill me. Nate. Nate, who, I don't know if you guys saw his React talk earlier in the summer. That was phenomenal. So he's going to do a React Native talk October 21st. I'm pretty sure he's doing a React Native talk. And they just released React Native for Android, so I'm sure that'll be included. So that'll be October 21st at Bronto, and Bronto always does a great job of hosting, so that'll be a good event. NC DevCon, it's coming up September 26th, 27th. Actually, there's like a whole slew of conferences coming up, so it's just a good time of year, especially with football starting. So that's September 26th and 27th. And then the guys from Angular asked me to mention this. Angular Remote Conf is September 24th and 26th. It's a purely online conference. I can't remember the price, but I'm pretty sure it's pretty cheap. And we also have a discount code for 20% off. If you can't see that all the way at the bottom, it's just Meetup. That's pretty easy to remember. And then this is the big one. Red Hat's a big sponsor for it. All Things Open. That's October 19th and 20th, and you can continue that high from the conference to on October 21st and come out to the React Native stuff with us. So that'll be awesome. And then we also have a discount code for that, TJS15, and that's 15% off if you haven't already registered. So actually, I think you were going to say so. Yeah. Yeah. Well, thank you, Bandwidth, for hosting us tonight. The pizza is great. This is a good room. Glad to be here.
So yeah, in return for food and shelter, I get to stand up here and tell you how we're hiring. Big shocker. So my name is Les James. I work on the web UI team at Republic Wireless, which is a division of Bandwidth. And we're looking to grow our team. So I know I get it. You guys get recruited all the time. Probably sick of hearing it. But if you get to, be creative with JavaScript in your day-to-day job, that's awesome. I'm so glad for you. Hold on to that job because it's a keeper. But if you don't, get to use JavaScript the way you want, if you're not working for an exciting, innovative company, if you don't have your dream job, then come talk to me. I'd love to see if we can make that happen for you. We write JavaScript all day. We make some awesome stuff for Republic Wireless. And if you think you can contribute to that, again, I'd love to talk to you. So thank you, Kyle, for letting me recruit, and get some jokes today.
So I'm still new at this. I realized I was just videotaping myself the whole time. But all right, so any other things that people want to mention before we get going here? Other job openings, looking for a job?
Hi, my name is John Long. I work over at Use Voice, and we are also hiring. And particularly looking for JavaScript front-end people. Also, if you've got any experience with the back end, we're looking for Ruby on Rails and Go programmers. So, yeah, it's a pretty cool company. San Francisco style startup, that kind of deal. So, talk to me.
Danny Holyfield. Hi. We're hiring on my team at AT&T right now. We're in particular looking for people with Ember.js experience.
Anyone else? I know there's a position at a company called Landcope. They're also looking for an Angular UI person. So if you're interested in that, they're based out of Atlanta, but they've got a small group of people here in RTP, and they're definitely looking to add somebody for Angular UI. So if you're interested, let me know. Besides the 2 or 3 big conferences that I mentioned, anything else that anybody wants to mention? Okay.
I got one thing. Speaking of all things open, the Ember meetup, we're going to try to keep an eye out on meetup. We're also going to have to try to get an Ember meetup that week.
we got to do a better job of like coordinating because like I've got a buddy who runs a Google developer group where we just always seem to schedule on the same night. He gets angry with me.
But we're also going to try to see if there's a few Ember 4 people coming out. Things that we'll try to get them.
Are you guys going to try to reschedule that the one you said to cancel?
Yeah, we'll have to talk to the guy, Jeremy, I think, from Citrix.
Right, yeah.
See if he'll do it another night. He said he would put it out, he'll put a video out of it, but
okay, we're interested because we're learning slowly, becoming dangerous.
Yes, but he's grown.
Yeah.
Okay, so here's the deal for tonight. If you haven't done these before, they're really fun. It's supposed to be like a fire hose, lots of knowledge sharing. So we say 10 minutes. It's really as much time as you need, but try to keep it to about 10, no longer than 10. So you're free to come up here and project. Just get up here and talk. You can talk about anything JavaScript. I say JavaScript related, but I mean, really, we're all developers. So anything relating to, I don't know, I guess CSS, HTML, Node, anything really. If you got some cool trick, you've got something that you're working on. We had a guy get up and do a code review. I mean, he just put his code up there and said, "Please, let me see what what am I doing wrong." So this is this is for all of you guys. So who wants to go first? There's got to be somebody. I'm gonna make Ian go first. You don't want to? All right, hang on. We got a volunteer back here. No. He's the stock. Like he was my fallback.
That's on testing. It's kind of boring. So let's go.
All right, and I think we've got the.
HDMI.
Let me grab HDMI real quick.
Oh, I can do.
What is it? Mini DisplayPort
yeah,
and
that's fine.
VGA.
That'll work. Hi, I'm Patrick Mueller. I work at NodeSource. We specialize in. Oh, let's try to see it. We specialize in enterprise node stuff. Used to work at IBM. If you've seen me around, I just switched jobs this year. I'm going to try to mirror this real quick. Find it. Right, display. Stop. Oh, okay. Range. So I'm going to be talking about. ECMAScript Node 4, version 4 release, which just came out, and some new ECMAScript stuff that's in there. Okay, finally, so I can see it. So, ECMAScript 6 goodies, and a node for it. All right, so this is up on the web page if you want a copy of it. Okay, so Node version 4 was just released, I think, last week, maybe the week before. Anybody hear about that? Very cool. It's really the converged IOJA, when IOJS split off, and then so they converged, and now there's essentially no more development going on in the IOJS space. It's all back in Node. And because of the way IOJS did their versions, the new release of Node is now Node version 4. And they're trying to strictly follow Semver. There's a whole lot of stuff kind of going on around it. But it's been a lot of work by my colleagues, contributed a lot to that, and just the Node community in general. So beyond all the kind of rigmarole with the release, there's some brand new stuff in, and that's ECMAScript 6 features. And the reason they came in is at the last minute that are new kind of to the Node world, because they pulled in V8 version 4.5 kind of at the last minute. I'm glad they did that. A little risky, but very cool. And V8 4.5, which is the engine for both Node and Chrome, has a bunch of new ECMAScript 6 stuff. So, and it turns out that's also that same level is shipped in Chrome 45. So all the stuff I'm talking about tonight, even though I kind of focus on Node, is actually available in the latest Chrome as well. And then I got a link to even more junk, and I'm sure my colleagues, once they see this, will say, "No, you forgot to talk about blah blah." So I'll probably add stuff to it later. Okay, so I'm just going to talk about 3 of the features. One is template strings. It's a new kind of string. Classes, which probably everyone is more or less familiar with, but there's some new syntax available, enabled, and arrow functions. And by the way, all this stuff is standard sort of ECMAScript 6 stuff, even if you are running either on like an old version of Node or for other browsers that don't have this stuff. There's this awesome library called Babel, B-A-B-E-L, and it will compile ECMAScript 6++. It includes some ECMAScript 7 stuff in it as well, to a very generic version of JavaScript, so you can use this stuff kind of anywhere. And we use that a lot. Okay, so let's start in on template strings. So here's a simple example. And the basic idea is, actually, these new strings have backticks, if you can see that. Instead of single quotes or double quotes, it's backtick. And there's a couple interesting features with it. There's interpolation, like you would see in a lot of other languages. So in this particular case, I'm telling it, hey, insert the value of y at that dollar brace y and x at x. And so when you run that, it prints hello world. The other kind of cool thing about it is it does multi-line strings finally. We finally have multi-line strings in JavaScript. So that's very cool. But there's another kind of thing in it called tagged template strings. And so this is a use case. This is some, I tend to write this kind of code all the time. If I'm writing a bunch of lines out and I don't want to use string concatenation, I'll put them in an array, then at the end I'll join them. And for some reason that feels better to me. And I thought this would be a good example to show with these tag template strings. So this is kind of the old school version of the way I would do this thing, where I push a couple strings and then print them. And then here's the new version. And what you can see here is that my template strings have this P in front of them. And P is coming from this thing. P is actually a function. I'll show you the implementation of that in a little bit. So you can actually put a prefix in front of an identifier in front of your template string. It's a function, and then there's a signature for that function to have it do something special, and you can do all kinds of crazy stuff with it. So in this particular case, it kind of does, if you look at the bottom there, they're doing the exact same thing. And this was just an example. I would actually use multi-line string support at this point to do this. But so here's this interesting piece. This is that line poster where the function came from. And this is kind of noisy because the business logic is in here with dealing with the strings. But the special thing that's going on here in terms of and again, that there's this P function that's getting returned right here. And so this is kind of the magic here. This is what all of the tag functions end up calling. Basically, they take the string template, there's string literals in there and things being interpolated, and they give it all to you in kind of pieces, and then you can put it together however you want to. So here's an example. If I just say p hello, it ends up calling all the literal pieces as array elements, and then the interpolated pieces. The interpolated are always one element less than the literals, just because of the way they split it up. So the example here is, here's a longer one, and this has two literals in it, this line number colon space, and then the ending space, which is right here. And then the interpolated value, which is 2. So when I write this, it's like I'm invoking this. And so if you write a P function, or any, whatever identifier you want, with this kind of signature, it'll do what you want. And here's a simple kind of interpolator function. I just used underscore to kind of functionally deal with the stuff to join it up and stuff like that. So this is a pretty cool feature. I haven't been using it lately, but I probably will start to a lot more now that it's kind of built in. And so I got some links to some other information there. Another thing is classes. So here's like the old school way we did classes before. You had created a function, it was actually a constructor. You can't tell the difference between that and a normal function. And then you have to do this .prototype junk. And then you can kind of use it like a class. And then here's the same version with the new class syntax. So it's very nice and clean. There's some stuff like not having to use the token function when you're declaring a function. You can just put the methods in here. There's static support, stuff like that. So this does the same thing that the last one did. Constructor is was like the old animal function in this case. They actually split it out to be a named function called constructor. Okay, so even in old school JavaScript, you could do subclasses. Huge mess, and I wouldn't wish that on anybody. So here's an example of using subclasses kind of the new way. And in this case, there's no constructor, but what's going on here is that there's an animal, and frog extends animal, and then it overrides the species method. So if I call frog species, it'll return frog, but then if I call it on animal, it's throwing an error. And this is an old thing we used to do in Smalltalk days, where this is how you'd implement an abstract class, is you'd say, throw an error for an abstract method. Hey, it worked great. And maybe I'll start doing that again, I don't know. And then there's a thing with super calls. So you can use super to make a call up to the sort of your superclass functions. In this case, I'm calling super name on the frog, which calls the constructor with the name, so I only have to put that logic in one place. Nice and clean. My colleague Trevor Norris, when I told him what I was doing, he said, make sure you tell people that super isn't optimized yet. He's like insane on performance. So if you're using classes and you use super, don't put it in hot code because it won't be optimized. Okay, there's more information on classes. Last one is arrow functions. So arrow functions are a shorter way to, it's a couple things. One is it's a shorter way to declare a function. And then there's some special properties about it. So in this case, I'm creating a function. Its name is foo. And here's the actual syntax for the arrow function. And I have a couple different flavors here. This top one is a function with no arguments. And then it's just calling, it has one statement to it, And actually, I think in this case, it will actually return the value of console log. So like I say in here, it's kind of like having a foo function that calls console log. And then the reason why I did a couple different flavors is if you have one and only one argument, you don't have to put parentheses around your arg list. But if you have 0 or more than 1, then you have to. So so there's that. And if you're doing more than one line, then you can use braces. Okay, so now, so this all kind of works as you'd expect. The kind of cool thing with it is, what I think is really kind of the cool thing is that unlike normal functions, this is not bound on the call. It's bound to whatever the thing is contained within. So in this case, I have here's one of these arrow functions, and it's just calling some method here. Normally, if this was a function, I wouldn't, and this is a method in the same class. Normally, if this was a normal function, I wouldn't be able to use this because this might end up being something else when it was called from set timeout. So you have to resort to these, either bind it, or you have to like make a copy of this and just sell for that. And it's just kind of icky. So that's one of the things with arrow functions. You don't need to do that because it's using the context of this within the class. So that kind of gets you out of a little bit of the some of that icky copying or binding stuff you used to have to do in JavaScript in some cases. And you can of course use it outside of classes. I kind of like classes added in. So there's more information on arrow functions. That's it. Questions? Yeah.
Give me information on when tail recursion is going to come to there.
Is there something already in there already?
I know Babel can handle it if it's a function that calls itself, but otherwise, I don't know.
Well, yeah. So that's what I'm thinking. They, because there used to be a weird limit. It was like 50, or maybe it was 150. A stack limit on recursive calls. And I did like your idiotic factorial implementation a while back. And I was like, oh, this was a stack when I ran it. It didn't. So I might have gotten lucky and had the right kind of signature that enabled it to do the tail recursion stuff. I'm not real sure. Yeah.
I know there's a set immediate which does a sort of similar thing, but I'm not sure what that is.
Set immediate, I think it was kind of like a timeout,
Yeah.
but scheduling it in a different place. So there's like a bunch of different.
I forget which was which, but one of them was just like set timeout.
Yeah, there's set timeout 0 or set immediate. There's another one which I can't remember, and they all kind of insert the callback in different places. Actually, my colleague Trevor, I believe, has a blog post on the what's it called, the event micro queue or something like that, because he works on this stuff. And so he actually had a blog post where he explained it all. I tend to steer clear of anything that requires that, or maybe I'm just lucky that I don't have to deal with distinctions like that. But there is some right department stuff if you need one. Yeah.
Do you know did the structuring assignment make it?
No! That's the next big one. I really want that. There's a bug or an issue in Chromium, V8 thing in Chromium that's tracking the work there. So I'm really interested in doing that because I love that. I did a lot of CopyScript, and so I made full use of that. And can't wait to have that. I think that's probably my next biggest thing I want.
You're using Babel now.
Yeah, once you start using Babel, then you just start using everything. You don't even think about it unless you have to look at the code. Kind of like that. I love Babel. Babel's awesome. Great, thanks.
browser, right?
Yep.
So I thought I would demo a little bit of D3 stuff. Is anybody playing around with D3 these days? Yeah. D3 is, for me, one of the most exciting unexplored corners of the JavaScript universe. It is very hard to explain in some ways what it's useful for until you start playing with it. A lot of people use it for graphing, but you could actually replace jQuery with it and use it to manipulate, the DOM in the same ways that you do jQuery. The big difference is that D3 is designed to bind data with the DOM, and so you end up writing these kind of update loops with D3 code essentially to update the DOM with the data that you have bound to it. And D3 also includes a ton of really awesome math stuff, which is what makes it great for graphing in general. So if you haven't explored D3, check out their website. Probably the best place to start is to just hop into their examples. And he's basically gone through how to create all of these crazy kinds of charts and things in D3, and you can click into one of them, and D3 does animation very, very well, and he'll have all the source code there for doing that. If you're doing any kind of data visualization, D3 is just an obvious choice. So what I wanted to sort of show off, I don't know if my screen's going to be big enough here. Let's see. Yeah, I can. Is that still viewable? So here I've just created, so we do Angular at user voice, and Angular in this case, I'm using it with D3. I'm using D3 for the graphs, and then Angular just to give me custom components essentially. So I wrote a little directive here for Spark line. You can see I've got 4 graphs over here on the side, and the basic idea with the directive is that you have an array of things, and you can add stuff to the array, and you'll see the graph change as a result. In that way.
So is that update happening in terms of?
This is actually CodePen. CodePen's kind of like JSPen or any of those sites, and it basically gives you a live editing environment where you can play around with demos, that kind of thing.
So the graphic seems very fast. I'm just playing with some of their demos and stuff, and I wondered, is it WebGL accelerated?
No, it's so D3 can do anything in the DOM, but it also specializes in SVG. And as I'll show you here in just a second, when we look at the implementation, you're just creating DOM elements and things. So let's see if I can make this just a little bit bigger. So my HTML, just to show you that again, I've just got a simple Spark line directive with some attributes on it. That's the basic thing that I want to map into D3. So if I turn off my HTML, turn on my JavaScript here, here's the directive. I'm just putting it in my app namespace to begin with. I'm not going to go over the Angular stuff because it would take far too long to explain in 10 minutes. The cool part here that I want to show you is the actual D3 building of the thing. So I have some configuration that's going on in the beginning. Just what kind of padding I want to be around my graph, the width, height of the graph. I'm grabbing that from the element itself, and then the data that's supposed to be with it, the stroke color, the stroke width, that kind of thing. And then I need two variables here, the max and the min, to figure out the size of the data that I'm plotting. So I'm just using the D3 functions for that. And then I build two functions is actually what these are. And D3 gives you the ability to create functions rapidly that do specific things. So this function X is what I'm creating. Maps the domain model to the actual coordinates on the rendered graph, basically. And Y does a very similar thing. It's mapping between those two. Basically, it gives you a function that you can pass a value to, say, like 23 in our data, right? And then it would say, okay, well, that's the equivalent of 10 pixels down on the graph, or whatever. And so I have two domain mapping ones, and then I'm using the D3 line helper to get the SVG line data. So this is another function that I'm constructing there. So the basic idea here, I select the element that I want to work on to begin with, and class is kind of like jQuery, add class. I just throw the Sparkline class on that, just to be a good citizen. Then I append an SVG element to it. I set the width and the height of the SVG. I'm going to go ahead, you may be familiar with this with SVG, but a clip path is a good thing to use when you're working with elements because it will basically cause the drawing of the stuff that's attached to the clip path to only appear inside the clip path. That's what a clip path is about. So if the chart goes outside the bounding box, it won't draw outside the bounding box of the clip path, essentially. So I set up a little clip path here. You can see I'm setting the ID of it. I'm appending a rect element to it. The attributes of where it's located, setting its width and height. That gives me the clip path rect that I need. And then very simply, I'm drawing a path element here. And I'm going to use the D3 functions to do that. The big one here is this one for the attribute D, which determines where the path goes. And I'm using my D3 line path again, essentially, to map the data that came in into my domain and draw it for me, which is crazy cool. So this is essentially the entire Sparkline drawing that you saw. To give you a little better idea of what's going on, let me show you what the DOM actually looks like. So here's an SVG. It's got the clip path element that we built, and then the path. And D3 calculated this whole D attribute of it for me right there, based on the input domain. So that probably feels a little magical, but the more you get into it, the easier it is. And you can see the cool part about this, in about 50 lines of code, I have a custom graph. And the more you work with it, the easier it gets. Here's a graph that I'm working on right now that has the full hover effects and stuff like that. And D3 makes this stuff trivial the more you understand it. So here we are. Yeah, that was kind of crazy fast. Are there any questions? Yeah.
You'll take your function append on the end when you added data, is that right?
when I'm adding data. You're talking about right here?
Yeah, I think so, yeah.
Yeah. So append is just the add this to the DOM.
I was-
Three version of that.
I was curious, how hard would it be to limit to like say it was like you had a little live graph which moved, like get rid of the front one so that you only kept like 10 latest elements, whatever.
Yeah, so D3 actually provides the ability to like transition things, and then so you can define like intervals for how it would be updated, and you can say over say 200 milliseconds, like transition this into a different state. So it'd be the same thing. A lot of times you'll see graphs where they will start at the bottom and they'll animate up into position.
Yeah.
That type of thing is very easy to do with D3 as well.
Does D3 do anything in terms of caching and interacting with internet or dispersed data in terms of holding it and concentrating it on a focal point or that sort of thing? I don't know whether I'm.
So jQuery, of course, does provide AJAX type functions and things like that, and D3 doesn't. It's strictly focused on the DOM, SVG manipulation. So yeah. All right.
Can you put your code pen link in the comments?
In the comments, how do I do that?
Meetup.
Go to Meetup.
Meetup.com/triangle. Yeah.
What is it?
Triangle hyphen JavaScript.
JavaScript. Okay, I will do that. Thanks so much.
My name is Doug, and I work in the building next door for NC State, and we are building things for middle school math education. And so, and we're using D3 very heavily. And so I wanted to show what I'm building, which is not much like what we just saw in terms of lots of data, although we will get into that. It's going to be really low on the screen. Maybe you can see my little widget that I'm building down here. Sorry, this guy's in the back. I could modify my code to get it to come up, but I just wanted to do something really quick anyway. So this is built in D3, and I'm handling all the mouse events and keyboard events with D3. And so it's interactive. So I can drag these. So this is a number line, which is used in middle school math very heavily. And this basically I built a D3 widget. Like D3 has lines and graphs and things that it comes with already. And basically I built a D3 number line. And it's very configurable, just like any other D3 component. Like you were showing, you set attributes on what you're about to show, and then you add it to the DOM. That's what I'm doing here. I've also built a little numeric entry keypad. And the reason I built it right in the SVG is to so I can point directly to what they clicked on. Because it's in the SVG, I can always do that very precisely. And so I can enter any other number here. And that number goes in that. Like, that's incorrect, but imagine that we've asked in a test, we've asked a student you know, what value goes here. Or there's a tick with an A, you know, marked with an A under it, like the A there. Put in the correct value, and it might be a fraction. So that's the other thing I'm using in addition to D3 is a fraction library. It's open source, and it's working great. So I've also worked out selecting a range. So instead of just clicking on the desktop, I'm Shift, click and dragging. And this also works on iPad with 2 taps. So I tap the range I want with a finger on each hand, or 2 fingers on one hand, doesn't matter. But basically, 2 taps define that range. This will work just the same. So here we might be asking the student to put a tick mark at, say, 11 thirds, or something like that, whatever's going to be in that range. So like I could divide this range from 2 to 4 into 6 parts. And then it's a little tight there, but in this case, I've configured it so that all minor ticks are open boxes for them to enter the number. But I could configure it so that it just shows the fraction. So anyway, that's the gist of it.
I got a question.
Yep.
Has anyone made games or any kind of more interactive thing for D3?
There's so much D3 stuff out there. I bet they have. It's probably not the best game experience, but you know, for education maybe. You know, have super high fidelity and so on.
How does D3 handle accessibility?
You're on your own, and that's something we need to work on. So just a little bit of code here before I jump off stage. So basically, here's my custom number line in our own namespace relative to D3 namespace. So I'm doing some configuration here. Here's the second number line, which you couldn't see because it's too low. So I define those, configure those, and in the typical D3 way, I add them to a group object right there. So I love SVGs, how they're very hierarchical, and the transforms flow down. So if I transform a group to be positioned here, everything I put inside that group is relative to that new origin, and I love it. It works great. Having a good time with this.
This is easy like 5 minutes.
Can you?
I've said that before, but.
Defaults.
Hey, cool. Oh, okay. Smear my screen over. Cool. Okay. So, not work-related whatsoever, but recently I've been getting into procedural content generation for games, not for anything other than this really interesting topic. And so that got me onto terrain generation for planets. So whenever you get into terrain generation, one of the things you really quickly bump into is this awesome noise function that Ken Perlin made for the movie Tron. Called Perlin noise. And Perlin noise creates random noise, but in a way that feels natural. So it's a really good way to get like clouds, for example, because it creates randomness without creating like mosquito buzzes on the TV. So that means it's really awesome for making planets. So this performs horribly, like using 2D context canvas with 2D rasterization of 3D vectors, which is really expensive. So eventually, probably what I need to be doing is not using JavaScript or throwing this into like a WebGL shader or something. That's really the way that I need to go. But that's not what I'm here to talk about today. Today, I'm here to talk about hot module replacement. So what is hot module replacement? So hot module replacement, as it pertains to the module bundle or webpack, is the ability for you to have a server that's watching your code that can send WebSocket events down to your clients and hot swap in new code whenever it changes. So this is not something that we're doing in production at work, or I've heard of too many people doing in production, period, because it's such like an attack threat. And it's also really complicated. But for development, it's a fantastic tool, and I'll show you why. So let's say I'm working on this planet. Let's make sure I can clean up. And I'll bump this up in a second. Cool. All right. Okay. So can everyone see this okay? Tell you what. That's all that matters. Okay. And I'll change to a different theme. That might be. Is that better or worse?
Worse.
Worse? Okay. Okay, so yeah, so the way that this works is that the code is horrible, but basically I create a matrix of Perlin noise, and I bind that I convert that using polar coordinates to convert it from a 2D to a 3D coordinate around a sphere, and then I determine the color that you see based upon the noise value, which is anywhere between 0 and 1. And so to get that color value, I've got a color table that is an awesome if statement, fantastic. But the idea is basically, all right, so if the noise is less than 50%, that means we've got ocean, so paint it blue. If it's higher than that, you know, let's let the, here I'll actually zoom this in, because this is Chrome. All right, so we actually have some depth there, maybe you can't see it. I'll fix that in a minute. But we have shallow water and we have deep water. And at some point we hit like the surface. We exceed the water level. Or we exceed sea level, excuse me. So we hit beach. And so when we hit beach, then we want to spin all the way up down from 220, which in the HSL color wheel is a nice lovely blue, all the way down to 60, which is a yellow. And we jack up the lightness so that, so we decrease the saturation down to 30, and we increase the lightness to 70 to really bump it up. And then beyond that, we make it a little bit greener, and then everything else higher than 75, we'll just do a simple calculation to figure out how green it should be. But what if I don't want to make, you know, Earth? That's really boring. So to do this, what I have to do is go in here and let's change this value to, well, we don't have to use HSL. I can just say pink. So what I have to do now is I have to go back here and refresh my page and get, oh, there it is. Okay, found it. All right, so now the really deep water is pink, which is kind of goofy. That's fine. So you can imagine, like, going back and forth and refreshing the page is really annoying. So what hot module replacement lets us do, got my color table here, so I can say, well, if the module namespace is hot, I can say module.hot.accept the path color table. When that happens, I get a callback. And so what I'll do then is I'll just say color table, Actually, let's just rewind it, shall we? Right there. So actually, I originally did this in ES6 and had import statements, but import is basically the same thing like as a const binding. So you can't rebind import namespaces. So I had to cut that for the second example. But this is it. We've got a module replacement set up. So now I've got a little earth here. So let's say, let's go back. Okay, so let's go back here and let's make this pink again. Boom, pink. Pretty cool, huh? I'll open up the console here and I can show you what's going on here. So you can see here in the console, it connects the WebSocket connection. It detects that app.colortable.js changed. That sent out the WebSocket event. We accepted it in our code and we swapped in the value on the fly. So let's say, I don't know, let's jack this up to, well, let's lower it down to like 60. Now we have red grass. Let's remove this top one here. Really this one here too. No, we want that's the beach.
Okay.
But let's say we want like ruby beaches or crimson beaches. That sounds great. Crimson beaches, pretty cool. Likewise, we can make the ocean purple, lavender, and green, lime. Now we have a pretty awesome looking planet. And so the cool thing about this then is that I can just do this like as I'm developing, and I can have this up on like a secondary screen. And this is really kind of trite for the sake of this example, but like there are a lot of plugins in the community, specifically for the React community. There's a hot module replacement plugin for React. And so whenever I'm working on a project now, I don't refresh the page, period, because it's sending down updates on the fly as they're happening and patching them in, which is a really fantastic development experience. And I'll make this black at the end here. Black clouds. Do I have any clouds? Yeah, there they are. Black. So that's it.
How often does it not work? Fail? It doesn't, it never fails.
So it typically fails whenever you have, so obviously the reason why this works so well is because there's no real state here. That's why it works so well for React, is React components are, for the most part, stateless, or at least it's really easy to detect what is coming in and what's coming out of a React component, so it's easy to swap out. This does not work if you have stuff that's not idempotent, so it's got to recall itself. Even with React code, if you have something like a date.now inside of your component, it's totally going to update with that new value because it's reevaluating that function. If I do get an error, there is some neat reporting. So I'm using a tool that's basically like, it's the hot module replacement middleware for Webpack. And I'm plugging that into Browser Sync. If you've heard of that, it's like a live reload thing. It's an Express server, so it means we can put like other Express middleware into it. And so if I make an error here, like I forget a line, it's gonna tell me I got a build error there. It's gonna say, you know, hey, fix this code. And if I go back in and add that back, it's gonna error it again for me.
Nice.
Which is pretty neat. Yeah. Gets really handy for things like if I'm in the middle of debugging something. I'll go to the sources panel. Let's say throw a debugger in here. That catches it immediately, and I can see, oh, noise is 0. That's interesting. And then get rid of it, and then I'll have to click play. But play. So there's an error. So what happened there then is that it didn't pick up the event because JavaScript execution was paused. So now I have to refresh the page. I'd say, yeah, bye.
Thanks, Obama.
So Yeah, again, it's like not something I would feel comfortable with or see too much utility with for production stuff. But like for a production like website that's consumer facing, but certainly for development tools, it's awesome. It's fantastic.
So like with React, it doesn't recall like get initial state or something, it just uses the state of the previous component?
Yeah. So for that particular plugin, it actually creates a proxy in front of your React components and like sits in front of it. It knows the state of the component and then reruns the methods that have changed.
Whereas if you like try to replace a store in React, it would probably double your data or something like that.
Yeah. So I know we have a Flux implementation that's stateless, or not stateless, but stores are stateless. There's another one too called Redux, where the stores are stateless, and you can totally do hot module replacement with that. And then in that case, all it does is it just reruns through all of your actions you pushed. And since the stores are activate, stores that act more like reducers, then it can like re-identify what state it was based upon previous actions. So any stuff.
This isn't much about the code, but as far as procedurally generated Planet games, have you seen No Man's Sky?
Yes.
Okay.
Yeah.
Just making sure I figured you would have.
I'm not that ambitious, but
Yeah. Well, I'm assuming you're stoked for that game. Yeah.
yeah, it's amazing.
Let's give us a magic button to remove. You have a magic button to turn on mirroring.
Oh, can you split? I don't know.
I'm on a Mac. Here. Okay. To introduce myself, I'm Adam Hale. I have my own software development company. I'm my partner in Durham. We do a lot of web and mobile app development for contract. We work with a lot of companies who are doing greenfield new products and either don't have the internal resources to build them or don't feel like their internal resources are up to snuff. I've been a lead developer for many years, so I think a lot about software design patterns and ways to build software and points where I've seen my team hit friction. Before that, back in the late 90s, when I was still an academic, I was interested in functional languages. That interest kind of still continues, particularly in the domain I'm going to talk a little bit about here, about functional reactive programming languages. So this began SJS. This is a personal project for me. We actually have used it in one work project now, but it's really something I do on my own time, out of my own interest, and lingering curiosity and intellectual energy not burned off by my job. So what is SJS? SJS is a tiny library for simple, clean, fast, reactive programming in JavaScript. There's a GitHub line there, which is a lie right now, and will be posted tonight. Reactivity. Reactivity is about dealing with change. We deal with this all the time in our applications. But just to start up, just the simplest basic element of a program. We've got some data, we apply a function to it, and we get a result, right? Repeated thousands and thousands of times in all the programs. But the issue there is that this is really only a point-in-time result, right? The result that we calculated depends on the current state of our data. If anyone anywhere changes that data, somewhere in the application, our result is out of date. And so how to deal with this issue? Well, as we know, we all spend our time building JavaScript applications. Can you all read that? Is that large enough and high enough, sort of? Yep. Every framework out there has got some strategy for dealing with change, some particular API, but they all follow one consistent pattern. Generally, they follow one consistent pattern, which is manual change subscription, right? So we've got Backbone, you subscribe to an on event with your update function, Angular, you can use like scope.watch or digest some of the other functions. Ember, I don't really understand, but it extends the function prototype to have like function.observes or on or watch or various pieces there. We're using React and Flux. You got a change listener to your store, right? All different ways of handling the situation when your data changes and you need to update the result. Okay, what are the problems with this pattern? These will be things that will probably be very common to you, given that you all are developing JavaScript applications. First one, so manual change description requires that we iterate all the pieces of data we use twice. Once in the body of our program, right? Here I'm doing a pretend backbone application. So we've got like data.get property down in our body, but then we also need to describe specifically to like, here I've called the properties foo and bar, subscribe to foo changes or bar changes. And I've seen all the time in, say, bug fixes, someone else comes into your code because they need to do like in situation X, also do it this other way. So they add in like a data.get down below, but they forget to add to the list of change subscribers. So as a result, you've got a bug that's difficult to deduce and will only manifest in certain situations. So tedious and brittle. Problem number 2, it's inefficient. If your network of change propagation is very simple, you won't notice this. But if you have a more complicated, layered, combined network, like a diamond here, I've got A, B, C, and D, you'll see the pattern that it generally, in these manual change subscription, because they're very local, change propagates step first. So if you see the numbers over there on the diamond, this is the order things are evaluated, right? If you have a change at A, it goes to B, then to D, then over the other side of the branch to C, and then back to D. So D runs twice. You can build graph topographies here that will make our endpoint run in squared or 2 to the n or even in factorial, depending on how complicated your network is. They call this in the reactive literature the diamond problem. Third problem, it's inconsistent. This is actually the one that has bitten us the most in some of our applications. That same propagation pattern, right? And D gets run twice. But the first time it runs, B has been updated to respond to the change in data, but C hasn't. As a result, we need to harden D that, hey, when you run, you might have some state over here that you won't see on the other side. Sake of brevity, I won't go through application situations that have led this to cause that. But you can think of like if A introduces a new element, B produces some product from it, D is expecting to do the results of applying B and C to that new element, but it doesn't find it in C. You get an undefined, you get an exception, the program falls over. They call this the glitch problem. It's an inconsistent situation in time. B is now, if you imagine, we start on time 0, the update of A happens at time 1, B has state as of time 1, C has state as of time 0. You can't see it at all here. My background picture is the scene in the Matrix when the cat, you see the glitch in the Matrix? So, problem number 4, manual change subscription is zombie prone, right? Subscriptions, they double link the call graph. Our function already references the data it needs. Our subscription references from the data back to the function. Since we've got a double link graph, it's never going to GC. They're going to stay around for life unless we have to go in and manually change that subscription. If we miss one subscription, somewhere in our application, it never gets GC'd. Not only that, but a lot of code will stay live. I'm sure many of you have probably worked on code, particularly from younger developers, where if you've gone to the widget 16 times, all 16 DOM elements are still active in memory, and you make a change, and all 16 of them are responding to it, even though 15 of them are even in the active DOM. Well, no, you've seen this one before, right? In the reactive literature, they call this the resource problem. It's not relinquishing resources. Okay. So what's the core problem here? Manual change subscription treats change as an afterthought. All right, think about the way you build your application. First, you build up your hierarchy of instances of classes. Then, after you built your object, you subscribe to the change events. It's object-oriented programming design, which knows constructors and message passaging, and doesn't know change. So you build up your OOP paradigm, and then you try to attach change events on top of it. Hopefully you got them right, but the initial construction in no way helps you deal with subsequent change. Okay. So that's the problems. So what would it mean to treat change as a foundational principle? If OOP knows construction and message passaging, what would it mean to start out from the beginning, you're thinking in terms of change? Okay, that's really the goal and the project of reactive programming. At this point in some of our application development, I said, I know there are solutions to these, but they're like hassle.
We were using Knockout because you can kind of use its observables and compute it as sort of reactive systems, but they have a lot of problems, including the diamond problem. So I started playing around saying, all right, I like this. It's a good algorithms problem. It's about a 500-line JavaScript piece. This is a fun piece to play with. So I started playing around and writing my own library called s.js. S is short for signal, which is a term from reactive terminology. I'll get to that in a second. So, all right, so are some examples of reactive systems if you haven't worked with them in the past. The one that's always mentioned to explain it is spreadsheets, right? In our spreadsheets, we put data in some cells, we put formula in other ones. If you change the data, the formulas update automatically. The spreadsheet just handles it for you. You don't have to think about it, you don't have to hit an update button or something. Well, some really crummy spreadsheets you might, but in general, it happens automatically. Some other reactive systems you may or may not have seen. Some of you work with Elm, and played around with that. It's a FRP system, has this whole language and runtime that compiles into JavaScript and runs in the browser. Some are using Meteor. Underneath Meteor has a library called Tracker that is doing a version of reactive systems. If you're using React, you're probably using Reactive Flux. I urge you to take a look at another library that was introduced a couple months ago called Observable, which tries to add a reactive layer underneath React. On its own, React, despite the name, is not really reactive. Haskell is a reactive banana because anything that sounds like it could become popular in Haskell is toxic, so they have to give it names. Microsoft has RxJS, and like I said, Knockout even kind of. So, all reactive systems, just to give a really quick overview, have basically three fundamental pieces to them, all right? The first is some kind of data type for representing a value that's going to change over time. When we have just a normal variable reference, it only tells us what the current state of that variable is. It doesn't say, we want to follow this variable as it changes over time. This is usually called a signal, in reference to like signals engineering, like on an oscilloscope. It's a value that changes over time. Or it's called a cell, using the spreadsheet metaphor, right? A cell in a spreadsheet. The second piece is some kind of data type for one of these live functions, these functions that we want to keep updated. So as change happens, the function's supposed to run again. This one, names vary. The academic literature usually calls them behavior. People writing on the spreadsheet analogy call them formulas. I call them computations. Sean McDermott, who writes a lot of this on this area, calls them tasks. There's other terminologies. And then the last piece is you need some kind of system that's going to keep the two glued together. So when data changes, it's going to run your updates for you, right? It's the part that's supposed to make it seem seamless. All right, so s.js. S defines a top-level library called, or a symbol called S, and the constructor for a data signal is s.data. Its signature is you build one, you give it a little piece of data, that's what it's holding. It's like a little bucket, right? You can stick something in, you can get it out, or you can stick in anything. I've implemented it as a getter-setter function, similar to the knockout pattern. Like jQuery uses this on all of its properties, right? Although here, it's not like jQuery was attached to an object. These are actually their first class entities. You can pass them to other functions. You can attach them to whatever object you want. They're their own little atomic bucket. This is where we define the initial data of the system. That's where change is going to enter. The whole system turns on when we change one of these data signals. Thank you. So, piece number two, the functions we want to keep live. These are called computations. The constructor for them is just the S symbol itself. And what you pass in is a parameterless function that returns a value. And the signature returns is a new parameterless function that returns a value. Only this one it's going to keep alive. You can see that little bit of code in the bottom for those of you like in the front row. So we created a data signal that had 1. Then we created a computation that just took it, dereferenced it, right? Parent, it's a getter function, and multiplied by 2. And now the value of C is 2. Fair enough, right? Now, what React is doing behind the scenes, as you write these data signals and computations, it's maintaining a live dependency graph of your running code. As the code runs and morphs, the dependency graph grows and shrinks and changes accordingly. Maintaining this graph, then when you change a data element, it will propagate that change through the graph. It knows which computations are affected by that, which computations reference that particular data element, or which ones even are upstream from them, and so on and so forth. It will propagate that change up through the graph. The last thing it's doing is, as this graph is morphing, it will actually prune edges and nodes that are stale. So like, you have an if statement, one time the computation runs, it might reference a particular signal, but the next time it won't. That edge gets removed. And there's also a mechanism in which entire computations that are no longer relevant will be removed from the graph. We'll talk about that in a bit. So if you can see at the bottom, how many of you can see the code at the bottom? I should have flipped these things. Okay, sort of. So we define a data signal called name. It starts out holding s.js. We define a computation that just appends hello in front of the name signal. And then a printer that logs the hello value to the console. Okay? S is eager. It runs everything right away as soon as the change happens. It's not Haskell, it's not lazy. So as soon as we define that printer, it runs, logs to the console, hello, s.js. Now we go and change the value of our root data signal, name, to world. All right, so now that the data signal changed, S is going to rerun hello, which in turn is going to rerun printer, and hello world logs to the console. Make sense? Okay. So how does this deal against the 4 problems that we started with? We talked about manual change description violates stride. Don't repeat yourself, right? React, or S has, I'm talking so much about React, I keep flipping it to. S can see through your function to see which data signals you dereference. So like, here's sort of like how S sees your function. Okay, you had a computation that uses foobar, black, and yak. So I've created, when it runs, it creates dependency edges to those 4 signals. You don't have to then somewhere list out, I reference foobar, black, and yak, oops, I forgot one. It does it for you automatically. And dependencies, I would say they're exact by definition. They're exactly the dependencies that were referenced in the last execution of the computation. They come and they go as the computation changes. Problem number 2, manual change description being inefficient. Here, by definition, one change in our source produces one update for all referencing computations. Like in this, if the numbers have changed over there, now a change in A will run B. It won't run D yet because C hasn't updated. Then it'll run C, and then finally it'll run D. What this means is that no matter what your graph shape is, no matter how complicated a network we have in front of D, it's only going to run once. Problem number 3, the inconsistency. Again, updates run in topological order through the graph. Okay, so D here is only going to run after B and C have run, and it gets a consistent view of time. By the time D runs, everything it sees is at T1, not at T0 or T1. There are no glitches. Okay, problem number 4, the zombie proofing. Okay, not only do we prune dependencies that are no longer active, we can actually prune whole computations. And the model here is that computations in their execution can produce other computations. Okay, so they have those computations are considered part of the result of their parent. If the parent reruns, those sub-computations are all erased or disposed automatically. So an example that we might use this for, that little bit of code there, this is like a miniature router. Okay, we've all probably worked with whatever framework we work with. When the route changes, we change our view, right? We update the view controllers and services and whatever complicated machinery around that routing. This is a very simple one. This is a little computation that does our routing for us. So we've got a current view that we have to keep up to date. I'm not showing how we get that into the page. That would be actually only about 4 more lines of code. But in case current view is what we want to have displayed on the page. We have a signal called hash. This is using hash-based routing. If hash is equal to about, then we want to create the about view. If hash is equal to store, we want to create the store view. Now, when we create these views, there's going to be all kinds of computations created because we need to keep these views up to date as the data underneath them changes, right? We open the store view and add something to the cart. We need to have the view change to respect that. All that's going to be created as s.js computations. So what this means is next time our hash changes, because of those computations were created in the last update, all of them are disposed automatically without us thinking about it. So for instance, many of you have probably dealt with the problem of like having to clean the DOM, like but jQuery had a clean function which would release all of its callbacks on a particular node and all its descendants. Knockout has clean node. They've also got, there's sometimes a convention like if your object has a dispose method, you can put any cleanup code there and it'll get called by the framework. This is handled globally exactly without you having to do anything. No. And I was cleaned up. That was my last one. So, let me try. Oh man, I think it's power. I had like 70% when I started something. I think I'm dead. All right. No, that's fine. Well, apparently I'm done. All right. So I'll just chat for a couple things. I was mostly to the end anyway. I want to talk a little bit about the costs involved in this as well. You hear the stuff about maintaining a dependency graph, manual automatic registration, and deregistration. It sounds expensive. One of the fun things I've had with this is I've learned a lot about V8 internals. Currently, at the basic problem of maintaining a dependency graph, I'm about an order of magnitude faster than most of the major libraries out there, faster than Backbone, or Angular, or React, or Knockout, or Observable, or Tracker. There is some cost. So, I mean, if you're doing a heavy computation-bound system that doesn't really need to deal with change, this is not your choice. The other cost is in terms of syntax. Some people are toxic against the getter-setter functions. At some point, you'll do like, object.property equals something. It's not what you want to do. You want to do object.property parent or something, stick it in there. There's a cost in terms of the syntax that's around this. The advantage of getter-setter functions is they're very fast. Closures, as of about 10 months ago, became extremely fast in V8. They used to be slow. If you look at web advice from 2 years ago, they say if you're doing performance, don't use closures. That's no longer true. And the other advantage of getter-setter functions is that, like, say, they're first-class objects, which enables a lot of neat architectural patterns. But the last cost are really the biggest one. Yeah.
You're saying getter-setter functions, but you actually, your values are actually functions that you call either get or set.
They're closures, so they've got like an internal variable that gets set when you set it.
Have you looked at using property getters?
Object.defined property. Yes, I have. It's a good reason that one of the reasons I'm not. A lot of my 10x improvement comes from that. So, no, they're not optimized. These little getter-setter functions, they inline beautifully into your code, which is automatically going to give you a 4 or 5 times speed improvement. Define property in observable, which I was saying I respect them a lot. It's a neat library. They are using object.defined property. It makes your code very clean, right? It looks like just a plain old JavaScript object. But under the covers, it's doing all this reactive registration and so on without you having to think about it. So it is a trade-off. I have played around with, I mean, you can use s.js and proxy all your get and sets into an s.js getter settle that's maintained internally. It's still not my favorite. I might provide it just for people who want it. Yeah.
How does this translate into UI?
So s.js is half of, this is my hobby project basically, right? I have a web application suite called surplus.js. It's S plus a set of related libraries. It's really, you can see s.js is very functionally oriented, right? It's mostly about functions producing values. The other side of it is a library just for producing HTML DOM objects with an HTML-like syntax. So it looks like you're writing React code, only it's actually creating real DOM, not virtual DOM. One of the reasons in React we want to create virtual DOM is because then we can only update real DOM on the animation frame. I didn't talk about here, but s.js has primitives that you can control how and when change propagates through the system. So you take all your view code and say run on the animation frame cycle, and it will only update once without having the need to create virtual objects that then get flushed to the real. So yeah, and it's been, I wish I could show some code. I've got a version of Asteroids running on it, it's been a lot of fun because it's your function your code just all becomes clean functions defining what something should look like. It's declarative programming.
Have you seen the stuff they're doing in React 14? Just pure functions that return.
I've seen some, but yeah, right, where your component can just be like, it's just a function. Yeah, similar stuff. Like React is, it's just that view layer, right? I mean, it's got nested trees of components, but it's just that view layer. This is reactive technologies for often what comes below that. The application we're working on right now that actually is using s.js in production, it's our data backend. And then it all triggers out to calling .set state methods on React. Yeah.
Is there a chance you're going to post a link in the meetup page? Because it looks really good. I just like to see it more in depth.
When it's posted up?
Yes.
Yeah, I keep thrashing about the README. That's the only thing that's left, so I need to put it up there. I'll post in the comments when I get it up.
Thank you.
Okay. Any other questions?
Since you're working on the README, I've tried to get into React a couple times, and after the first 20 pages, I can lose it. And I'd really like to get into it more. part, if you have some favorite references.
For React or for
Yeah.
reactive?
For reactive in general.
Reactive in general.
That'd be awesome to have to do.
Yeah, it's worth playing around with Elm a little bit. I'll say that just to give you a sense. Like Elm has a problem that Haskell has, and no one seems to be able to make a pretty looking application out of it. The prettiest thing they've ever produced is their 2D MVC demo. Otherwise, it's a lot of little boxes and squares. Oh, look, when I click my mouse, it moves. Great, guys. But it's one of those things like learning Haskell. It'll warp your mind about how programming works a little bit, which I enjoy.
Yeah, my mind hasn't warped there yet.
Right.
So I'm trying to find a good kind of book to help.
Elm's got a nice wiki around it right now, and a pretty interesting community. So that's one place to check out.
The paper that he published for his thesis on Elm.
Yeah.
Through the Elm website, there's the paper he did. That was his thesis for Elm, and it's really great. So like his whole thing is like that this should be approachable for learn JavaScript developers. So it's very, very targeted towards that audience.
Awesome.
There's also in terms of like the kind of things that can be done with reactive programming. You've seen Brett Victor's talks,
Yes.
right?
Yeah.
Okay. And the other person I'll mention, this is coming a little bit from the academic literature. He writes really for software engineers. Is Sean McDermott at Microsoft Research. We swap notes, and a lot of my algorithms I've stolen from him. I'm doing some things a little differently. He's got a couple things. One about his programming language glitch, and superglue, and about managed time, in terms of the abstracting about time in the program. Any other questions? Thanks for giving me extra time. I think I went like 10 minutes.
Yeah. You have problems with other syntax, like I said, it bothers you, you're going to hate this.
Yeah.
My name is Monty. I want to talk about ClojureScript for JavaScripters, and you might be wondering why. Pretty much up until recently, if you wanted to do anything on the front end, you were using JavaScript, unless you were writing Flash plugins or something like that. But of course now, JavaScript is becoming a compile target. And to all these languages, some very close to JavaScript, like CoffeeScript, or some like Elm, which is more like Haskell and far off. But the thing is, these languages that are compiling to JavaScript are having an effect on CoffeeScript. So from the syntax from CoffeeScript to JavaScript, or as we'll talk about ClojureScript, say in the whole kind of React thing. So I just want to give you a sense, and if you hate it, it's only 10 minutes, and it'll be gone. So what is ClojureScript? Well, in 2007, Rich Hickey came out with Clojure, and the idea of Clojure is it was a list, and it's a functional programming, but it runs on the JVM. And so you write a list, and you have a new language, but all of a sudden you get all of these really mature libraries, and it can run everywhere that Java does. So in the enterprise, anywhere Java runs. And so very practically oriented was his thing. So then in 2011, he released ClojureScript, which is basically Clojure, which compiles to JavaScript. So I'll kind of go back and forth. So essentially, they're not two different languages. They're one language with two different compile targets. And why did he do this? Well, he says because Clojure rocks and JavaScript reaches, right? Clojure is, or Java is a whole lot of places, and then JavaScript is kind of everywhere else. And it takes the same very practical philosophy of wanting to use the libraries and all the tooling and all the great stuff that's been done for JavaScript and kind of use that from day one. So if you want to try it out, you can go here if you have a laptop and start plugging it in, right? That's the kind of the funnest way. Try coj.com. It'll lead you through. Otherwise, if you look at data structures, it has all the sort of data structures that you would expect, strings and booleans, the numbers, since it's compiling JavaScript, are JavaScript numbers. It's got a keyword kind of a thing, which is like a Ruby symbol. One great thing is commas are treated as white space. So when you're making, this seems like such a little thing, but it's awesome if you're making a map or array. You don't have to put commas in all the time and worry about that. But but down there towards the bottom, you see a list. And that is the most fundamental thing about a list. Because list is actually a contraction of list processing. And the reason for that is you might be familiar with a list. A list sort of like an array where it's a data structure and it holds data. But in a list, it's also the form of code. So code also takes the form of a list, and it has this really cool name. So that's homoiconicity. So if you want a name to sound really pretentious, drop your friends. That can be it. But this is the power where you can treat code as if it's data. And there's a lot of powers that come out of this, is because this is where macros come from, and you can do a lot of good stuff. And I'll mention something a little bit about where it's sort of like the superpower of the language. So let's talk about those crazy parens, because if you hear anything about lists, it's, oh, the parens are crazy. One, they won't make you blind. Two, if you look at your JavaScript, there's a heck of a lot of parens in there anyway, so it's not a whole lot extra. But there's something about list. So you see a bunch of lists here. So here you have an expression, and every list is kind of an expression. And in this case, you have a list of numbers. But what happens in a list is it takes a look at a list and takes this, and whatever is here in this first position, it treats as a function. And it evaluates that function, and everything after that in the list are passed in as arguments. So in this case, it's the function, which is partitioned by. It takes another function, which in this case returns a Boolean, and it returns you a list of lists of these numbers. That's not so unexpected. If you look over here and you're looking at what's kind of weird about that, it's kind of math, and you can kind of get over, it's prefix notation instead of infix notation. But what's surprising is the plus sign is not an operator, it's a function. So it's a function that takes numbers and will add them up. Same thing, the equal sign over here. That's not an assignment, that's equal, but it's not an operator, it's a function. It takes a number of values and it tells you not whether they're not equal or not. And then the lists can be nested inside one another. So here it works from the inside out. So here it evaluates 5 times 6, and then takes that result, passes it in here, and adds it 1 plus that. So it's very predictable in that sense. You don't have to remember precedence and all these different operators. It's just function all the way across. So that's sort of a taste of functional programming. And you said, well, hey, JavaScript does functional programming. What's the difference? And of course it does. You can pass around functions and call them and all that kind of stuff. But there's a feature of a lot of other functional programming languages that they sort of share that JavaScript does not have. And here's some JavaScript, which can look good to your eyes here. But if it's a little quiz, what is X? So you assign an array to X, you do something with X, and then you add a 1 to the first element. What is X? You have no idea, right? So this is what you warn against with kind of global mutable state, but any kind of mutable state actually runs the same thing. So here's another little quiz, and this is two things that do the same thing. One, this is assigned to A is assigned to B, A is changed, what is B at the end? Give you a second to look at that. What's that?
Yeah.
So it's different. In the first one, B stays the same. It doesn't change at all. In the second one, this does change to take the new value. Why? Strings are immutable. Arrays are mutable. And so it leaves you, in this case, because of the immutableness, leaves you not being able to track what's going on. So the benefit of immutable data structures is it allows you to reason about your program and keep inside. You're not worried that something somewhere else in the program is changing a value that you need. So the thing with Clojure is it's not just strings, but all of the usual data structures are immutable. So maps, vectors, which you think of as arrays, they're all immutable. So if you make a copy, you're always getting a new copy. The difference is you're always dealing with values rather than sort of locations in memory. So it's always a value and not a pointer to someplace in memory, and that's what can change. That's how the mutability happens. Programming that way takes, there again, it's a little mind-bending, but it makes everything much more predictable. In my mind, it's simple. And the other thing is it's also more performant. So there's been a lot of talk about React.js, which is awesome. It has this kind of declarative way of treating the DOM. And it's highly used in sort of ClojureScript. And there's a number of wrappers around React in the ClojureScript community. David Nolan is one of these just super productive programmer guys, and he has a library called Ohm. And after React came out, he put a wrapper around it, and he was finding that he was getting performance 2 to 3 times faster than just React. How it is, and you're like, well, how is that working, right? React is written in JavaScript. He's compiling in JavaScript. How can it be 2, 3 faster times? The reason is because he's using immutable data structures. And so comparing 2 values is a lot faster than comparing 2 references or 2 locations in memory. And so it turns out to be a lot more performant as well. The other thing, and this is kind of to jump to a different part of the language, just to try to hit all the high points. It has to be, this list has to be compiled down to JavaScript. How does it do that? In the philosophy of wanting to use sort of the best tools that are around in the environment, it uses the the Google Closure tools with an S. I highlight that because it messed me up. And you say, well, I don't need that. I've got Uglify or something like that. But what this does is it actually has dead code removal. So it will look through your code, analyze your code, and if there are functions that are not being called, they will not be compiled into the end result. So you can have a big, hairy file, and as it analyzes it, it will just leave those things out. And you say, wow, that sounds awesome. Why doesn't everybody do that? Because programming and writing code so it will interface nicely with this is not fun. So no one does it. That's why none of the other libraries do it. The benefit is ClojureScript handles that for you, so you get the benefit without going through all of the ugliness. Just sort of wrapping up here. These are just a number of features that are coming to JavaScript, and they're already in ClojureScript. So sets as a data structure, lets in terms of scope, modules, these kind of rest and spread, destructuring, it's already there. And then promises, and this is the one other thing I wanted to come back to. They have core async, which if you know about Go, Go is built on Go blocks. And those are implemented now in Clojure and ClojureScript, which is a great way of handling async type stuff where you can write it as if it's synchronous, but it really handles asynchronously. And that is all possible because of macros. So just to kind of give you a sense of sort of the magic and the power that can happen because of macros. This is just brief. If you're interested, hopefully you're a little bit more interested. I wrote a much longer entrance about this. There was a little 2D JavaScript game that I ported over to ClojureScript, so if you want to see sort of code side to side, that's there too. But if nothing else, I just point you, Rich Hippie is the author of both of these. One is called The Value of Values, and the other is Simple Made Easy. And they are definitely worth your time. And also, if you want more of the ClojureScript, the main wiki page has an abundance of resources. Questions?
Did I just see the ClojureScript is now self-compiling?
Yes.
So that's new. That's new.
That's like in a month. Yeah, the last month.
Yeah. So that's cool. So you don't need Java anymore to compile your Clojure, which you need to do.
Yeah, I think the Google. Anyway, there might be. They're getting there. It's just new, and I guess that's the other thing. It's a really new language, so the tooling is developing. It's it's kind of rough. I mean, that's definitely a bleeding edge kind of a thing.
The other question is debugging. So what's the debugging story?
Well, with like Chrome Dev Tools and stuff, it's great. I mean, it will take you right. It will actually take you to the line in your code, but it show you the ClojureScript, not the JavaScript.
Nice.
Yeah. So that's. Cool. Yeah, that's nice. Anything else? Thank you.
Yeah, it was actually logo variant.
On the back end. Purpose of WikTape is to annotate and playback subtitles for any YouTube video. So right now, if you go online and I love YouTube, I use all surf it all the time. One of the problems I have is that I love accessibility too, and YouTube has issues with accessibility because only the person who posts the video can add subtitles to YouTube for translations to their own YouTube video, and no one can just come in and say, "Oh, I have a transcript. I love, like transcribing things or translating things to different languages." You can't add it after that. You can't add subtitles to anyone else's video. This will be a good way to kind of add some functionality to YouTube and kind of show things off in JavaScript. So a little bit about myself. My name's Aaron Spencer again. I have a background in Python and JavaScript. So WikTape is built and YouTube does have its own automatic transcription and subtitles. That's like the computer listening to it and displaying it, but it's never really that accurate. I don't know if you ever turn it on. There's like blogs, Tumblrs, like all the available subtitles on there. And it's good for searchability. Live text is great. I love live text and hypertext. I love all that kind of managing terminals and stuff. So and I love Wikipedia and the whole accessibility and changeability of using internet as it is intended. So I'll show you how it works real quick. So this is a really simple front page of WikTape, and you can just add anything into the search field. You turn it off and reaccept the terms, it starts working again. I have to do it about every 5 minutes. Just want to use a video by Douglas Crawford. So right now there's no transcript, so you can go any language. It's all Unicode, and it lets you add any comment. Or if you have a very special language, you can also do some other category. So you just English pops up with some tips, pops up with a field to enter the transcription. I'm not sure if the sound's going to work, so I'm just going to kind of add some stuff here. So like, it says hello. So start saying that. It's best to transcribe first and then set the timestamp. So I just put that in there, and it should. Because it's automatic, it's already putting this in the DOM, it's already putting that 0 timestamp and the transcription line in there. Pretty sure if you start playing it, it's going to, you can see it down there. It's already displaying. So that's not exactly what it's saying, but so you can keep adding, and it's all very keyboard friendly to make it really quick to transcribe, so you can just keep adding fields as you go. And it automatically sets your focus here as you go down. And I'll show you so that's at the front end. But the back end is it's really just using the YouTube API and JSON data. There are standards for subtitles formats online. I just kind of thought to make my own format so it's easier for me to program. It's really just having a loop that says, hey, are you in, asking the YouTube API, are you playing? Are you status of 1? So 0, it goes, no. And if it's 1, it goes, okay, let's check this variable that has all this JSON data. And it says, okay, so what's your timestamp? And then do you have the timestamp of, you have that in the JSON? It says no. Or, so if not, or if yes, then it says, okay, so if it's at the 0 timestamp, and it's rounded to the 1 every half second. So say the 0 timestamp, it goes, okay, populate a hidden div and make it appear. And it appears for 6 seconds in JSON. So that's the JSON here. And if I start adding more text, you can see how it just kind of updates on its own. It's not a key up event. I think that, yeah. So you can start adding, and this will automatically add the timestamp where you're at. So once, or you can use a key combination to do it, and pretty much can transcribe and save. And it's I built a little wiki, so it's only showing you the latest updates. So I mean that's effectively a wiki, showing the latest updates, goes roll back. So there's no login. I had a login at the beginning. I said why? It's just you can go in, you can edit it, you can unedit it, you can change it. So it's all live there, and just save it if you want. But I'm not. That's kind of tricky. And it's built on, like I said, Python, Django, JavaScript, jQuery in it. I used Django for a while, but I decided against that. Mousetrap, I love Mousetrap.js, if you guys check that out. It's really great, really simple library for making key combinations, keyboard controls. It's hosted on Heroku. I use PostgreSQL, and my WSGI server is Waitress, and my YouTube API and HTML, CSS. So that's what's good.
What was your motivation for creating this?
Oh, I think it's a good project just to show like it uses database, uses YouTube, uses Python, JavaScript. But my initial idea was I had to watch a video in a crowded room. I didn't want to turn up the sound. I didn't have any headphones, and it was that Andy Samberg's speech at Harvard, commencement speech, just random, but didn't have any subtitles. And I thought, well, if Harvard doesn't subtitle the YouTube videos, then you can't expect anyone to do it. So I was like, I can't even find someone else's transcript of it. So that was my kind of motivation to do it. And I like, having it like making things open because not everyone speaks English. Things that be translated makes it should be easier to translate. But internet is global, and why not treat it like it's global? I like live text, and I like those Banner Bar Bush kind of hypertext ideas. Yes.
So are you going to support other video services?
I was looking into Vimeo. I limited just like kind of starts small, big YouTube. YouTube's great. and then Vimeo has an API, but I just haven't.
I was wondering if you mentioned you didn't have a log in, log out. I was wondering if you kept track of the history, so in case somebody just trashed your perfect good transcript, if there's a way where it's going to go back and go to a previous state, reinstate.
Yeah, it's a really I don't know. It's the best implementation of simple versioning, but every time you save, press submit, it saves a whole other row in the database. So you always have every last version just at the date timestamp on it. So there's no functionality right now to pull up the old versions on. But I can do it in the backend.
Yeah.
I can definitely do it in the backend in the admin. But because everything's timestamped. So we have multiple, because it's linked by video, ID, then by language, so then and then by date time. That's how the database works. But yeah, you can roll it back. I can roll back to the backend. So how much trash is. But my thinking was anyone can just make a login and trash it. So why not? Why do you have a login?
Yeah.
Yes. Yeah. You can always fix it. Go back as far as that. Okay.
I think we have time for the formal.
Okay, well, man.
You're lucky.
Yeah. So
So I tossed, thinking about it. Here you go. Tossed together some slides for this yesterday, and I was wondering if I would be like that guy who over prepared for this, but now I'm wondering if I'm that guy who like didn't prepare. These people have been so polished, so hopefully this will be good. So we had some talk about ES6 classes earlier. I wanted to talk about another spec that is kind of coming down the pipeline. It's not part of ES6, but is proposed as a future JavaScript feature. So I'm gonna jump through this because we've already talked a little bit about ES6 classes and where they came from. So you can do classes in ES5 JavaScript. It's kind of clunky. The one thing I do want to note though is that along with that, there are a lot of MVC libraries out there that use an implementation of classes: Backbone, React, Ember, Angular, and they all kind of have their own slightly different variation on how you create classes. So Backbone has extend, Ember has extend that is a different extend than Backbone's extend. React has create class, Angular has kind of its own things. So ES6 classes have kind of been envisioned as sort of a common point to kind of solve some of this variety of classes syntax. So they're nice and clean. We already talked about this a little bit. They do the same thing as before. There's browser support coming. Right now you can use Babel. So we already saw that earlier. The problem, I want to talk a little bit about some of the problems with that though. So they're not as flexible as what came before. You can't use properties on them. They're only for methods. And there's strictness around the pattern for child classes. So if you have a class, you can't put a property on it. You can't define a property before a superconstructor. This is a problem for Backbone in particular, because Backbone expects some properties to be defined before it runs its constructor function. So you can't just use a Backbone.model as a ES6 class right now for that reason. There's some workarounds. So React encourages you, if you want to use classes, to define all of your properties down at the bottom. And I think this is gross. The main problem I have with that is the benefit of the class syntax as compared to older versions of JavaScript is it brings everything together. It's clear that you have one cohesive unit of a class. The putting properties down at the bottom and separate from that totally kills that. You've lost that benefit of having one cohesive thing. So question, how do you make this better? Decorators are a proposed feature for the ES 2016 version of JavaScript. That used to be ES7, but they changed it. They're now doing yearly releases, so they changed it to ES 2016. The ES6 has sailed, but I think probably ES 2016 will actually happen because it's starting that way. So decorators are similar to decorators in Python. If we've got at least one Python guy here, but if anybody else has seen Python decorators, they work the same way. They allow you to customize classes or methods on classes at class creation time, and they give you back some of the flexibility that was lost with the ES6 class spec. So this is a very simple decorator on a class. You can see a decorator is just a function. It's a function that takes if you're putting on a class, it takes a class object. This is a little bit more complicated because it is taking an argument. So you have a function that takes an argument, and then that argument gets passed down to the decorator, which actually takes in the class. So in this case, you can put true, and that is put as an is testable property on class. So that's doing the same thing that the React code I showed earlier is doing. It's adding a property to the class's prototype, but it's doing it in a way where it's much more connected to the actual class. It's pretty obvious that the concepts are connected. Methods look similar. Method decorators take the class, the name of a function. That key isn't super helpful there. The key argument is the name of the method, and a descriptor that describes the function. So it describes what the function does and some of the properties of it. Is it enumerable in this case, and 2 or 3 other properties. So you can, in this case, this allows you to say if you're going to loop over a class's function, you can choose to make the method not show up. And that's something that you can't easily do with plain ES6 classes, so it adds flexibility. So I already said this, the decorators are just functions. They're not some crazy new concept that hadn't been in JavaScript before. You can take the decorator syntax and write it in old school ES5 JavaScript, and there's, if you look at the spec that I showed a screenshot of earlier, they have examples in ES5 of what decorators mean. They allow you to take a class and change it. One important thing, this is changing it at creation time. So if you put a decorator on a function, the decorator doesn't run when the function runs. The decorator modifies the function in some way, modifies the method, and that is what is then attached to the class. So when it's actually running, the modified version of the function is running, but the decorator itself does not run every time, so it doesn't add a lot of overhead. And it's declarative. Everything is kind of a cohesive unit. It all sits together. So give you cleaner interfaces. You can put properties on classes again. That's helpful. You can do mix-ins again. It would be pretty easy to write a mix-in decorator that takes a class as an argument and puts the methods of that class onto the class's methods. So that may be too small on there, but this is me playing around with creating a backbone view, or specifically a marionette view, with decorators. So some of the things that are properties in a normal marionette view get moved up to the top as decorators. And I actually get to clean up some of the interface. So in normal Backbone, you have an events hash that lists at the top all of your events. If you know Backbone and don't know what the @UI is, that's a marionette thing. But you list all your events, and then somewhere later in the function, you have your methods that the events correspond to. With decorators, you can actually put those events in line on methods, which make for a much better interface. If you're familiar with Python, that's much more similar to the routing in something like Flask or Django. And the way that works, it's in context of the information you want. And that on function is, I mean, again, it's just a simple function that you can go through in the debugger. Like this is something I've actually played with and built, and if when you're actually running through it, you can put a debugger in this and see what's going on. If you've got problems, you can run through it. It's just JavaScript. So where are they now? It's been proposed for next year. ES 2016 will be released next June. They've moved away from saying like, here are all the features we're going to fit into the proposal and we will release it when it's ready. Instead, they're saying we're going to release at this point with whatever features are ready. So this may not be in there. They have to have a final spec. Right now, it's considered a stage 2 feature, and there are 5 stages, I believe, 0 through 4, because we're programmers, of the proposal. So it's like halfway through becoming a finished proposal. Excuse me, stage 1, I'm wrong. So it's not quite halfway. It is available right now in TypeScript, so I don't know if anybody uses TypeScript, but they've gotten a jump on that, and you can use that right now. You can use it with Babel, but it's under their experimental flag, so you have to say that you're willing to use stage 1 features. Angular 2, anybody heard of that? And Aurelia, which is another MVC framework that was released this year. Both use decorators pretty heavily. There are plans for using them in Ember and React. Both of them are waiting for the support to stabilize for a little bit more for it to at least become like guaranteed to be in the next spec, and to have kind of a final syntax for it. Here are some examples from Angular 2 and Aurelia. So Angular uses it for, again, static properties. If they want to associate a component or a view with an app class, you can put static properties on it. If I'm explaining that wrong, I'm not an Angular developer, so somebody can correct me. Aurelia uses it for dependency injection, similar to the Angular concept on that. So there's a schedule for when this will get drafted, and it will either be included or not included, and it will possibly come out in June. If you're interested, I can post these slides in the meetup group. The top link is for the proposal itself. The second link is for Babel if you are curious playing around with it. That explains how to use it, and it also links to the proposal, and you can keep track of it. That's just what stage it's in as well. Cool. That's all I got. Any questions? I don't want to. I got it straight to 9. So maybe one question. No questions. Go. Oh, got one.
I'm curious. I've read the decorator spec. I was a little concerned. I mean, there's a lot of talk about them being declarative. They're actually mutative. They're modifying the class underneath.
Yes.
You know, languages that have really close to mixins in a lot of other languages, and languages that do have mixins usually have semantics for what if we have collisions between mixins. Decorators have none of that. It's last one wins.
Yep.
I'm worried where if you head into a brave new world of decorators, there's going to be collisions on method names and properties that are going to be difficult to diagnose.
Yeah. I think that's something that's going to need to be figured out over time. I mean, it's the point of it is that it's bringing back the flexibility that was in ES5, which you can absolutely screw things up in ES5. They're just functions, and so it definitely is a buyer beware thing. If you're bringing back flexibility, you're also bringing back flexibility to shoot yourself in the foot. I mean, I can imagine a more tightly constrained version of that, but that would then they wouldn't just be functions in that case. They would be some sort of guarded implementation that you pass a function to, and there would be more logic to it than that. And that, I don't think was the intent of this. I can understand the concern, but yeah, it's giving you flexibility to, yes, shoot yourself in the foot, possibly. Okay, thank you.
Is giving me 2 more t-shirts to give away. So extra larges, anyone? Extra large?
I got one, but
there's a pen and paper and a pen.
So I've got one thing. I got 5 minutes, no slides. And so what I'm talking about is debugging. So what I've got here is I've actually got a broken app. I filtered stuff broken. So of course we can add a breakpoint. This is my filter function. Right? We can add a breakpoint. That's fine. The filter into a breakpoint. We can build these variables, right? Now, as I'm trying to debug this, I might want to have added a console.log to this, right? So I'll go back to source code and console.log, reload the app, and I'll figure out my issue, right? Now, what I have to do is I have to remember not to commit the console.log to source control, right? So what you can actually do, and pretty much all of the browser debuggers, this goes all the way back to IE8, is you can use conditional breakpoints. So has anybody used conditional breakpoints before? All right. So the cool thing, and these are in other debuggers, is it's going to stop on this line if this expression is true. Now, most debuggers, that's all you can do, right? Now, because it's a JavaScript, we can actually execute any JavaScript code we want. So we can actually say console.log. And then we can say self results link. String there. All right. And so what's going to do is it's going to execute this expression every single time it comes to this breakpoint. But console.log returns undefined, which is going to evaluate the false. So it's never actually going to stop at this breakpoint. So now if I filter, we can see down here in the console,
I now have a new, basically log point here. And so now I've added a log statement that doesn't go into source control. And I can do this dynamically in my app. All right. And like I said, you can do this in Chrome, Firefox, IE, all the way up to IE8. This feature actually works.
Safari.
I believe Safari too. Yeah.
Hey, Safari.
And so that's pretty cool. And like I said, it avoids your devs committing, a bunch of console logs to your thing. All right, so that's cool, right? Another thing you can do with it is, in this case, I have an app where if I go to save this, if I go to do an ad here, after 10 minutes, that's basically the authentication. I'm going to simulate the authentication timing out. And I'm going to get basically a timed out error message, right? Now I got a bug about that, but I don't want to sit here for 10 minutes, right, waiting for it to come up. I don't want to reload the page and stick it for 10 minutes. So like if I just add a value, we can see I don't get the authentication message. And what I can do is I can put a breakpoint here on my method, and then I could go into the console here and change this status to this auth timed out. And I could do that in the console, or I could do that in the watch window there. All right, now if I do that, that's all great. I get my message, I can debug my issue, right? But every time I hit this breakpoint, I gotta go and make sure to do that. Well, again, I can use conditional breakpoints. And so I can just copy this code up there. Now, the assignment is actually going to return the value of the assignment. So this will actually evaluate true. So actually stop my breakpoint. That doesn't really help me. I can, however, wrap this in a void, which now makes it return false. So now every time I click add, I can force my authentication to come up. And again, this is a change I've made in order to fix my bug, but I'm not going to commit to source control. And so that's all I want to show you guys.
Instead of void, you just then semicolon false.
Probably.